Good morning, everybody, and welcome to this NBS webinar. My name's Ian Chapman, and I'm sat with Tom Murphy from David Miller Architects. It's a little bit of a double act for you this morning. I'm going to introduce BIM in a very much a basic way, by way of acting an introduction to some of the BIM platforms, and we'll talk about BIM objects and how manufacturers can benefit from the world of BIM. And I'm going to hand over to Tom, who's going to talk about how he's using BIM in practice, and then we'll wrap up at the end with a quick summary from me, and we'll take it from there. In terms of questions this morning, if you'd like to pose your questions via the question console that you have via the webinar, we'll try and keep an eye on those questions, and if we can answer them at the end, we will do. If not, we can follow up answers to all the questions via an email to you. We'll just take it as it goes this morning. Okay, then, well, let's get into BIM. I've got no presentation as such this morning for you. I've jumped directly into Revit, so hopefully you can see Revit on screen now. There's a quick introduction to me. I'm a chartered engineer and director of the National BIM Library here at MBS. I'm also a board member of Building Smart International. Building Smart is an organisation that is a not-for-profit company that creates a lot of the technologies that make BIM happen. So you may have heard of some technologies such as IFC, or even maybe just heard of the phrase Open BIM. Well, Building Smart's standard-setting international body that helps to create those technologies. I've also done some work with British Standards Institute, sitting on their construction BIM panel and implementing some of the BIM standards such as COBE and other jargon and technical stuff that we need to get in place to help BIM work in the UK. But essentially, what I would like to say as an introduction is don't be frightened of BIM. A lot of you as manufacturers are probably already doing lots of clever things with CAD. You've probably got lots of information systems, and BIM is really very much an extension of that. The big difference with BIM is that it presents an opportunity you to include more information within your CAD geometry. So often you've got CAD details that will define the physical characteristics of your products, but it's fairly rare in that environment to include lots of technical information about how that product might perform and so on. BIM really marries the geometry and the information about your products together, so you can create intelligent objects that can work in today's BIM platforms that help designers, such as architects and engineers, analyze the products in the proposed designs. This avoids double handling of data and will result in kind of better outcomes and better designs as a consequence. Common question that everybody gets asked, really, that everybody ponders with, is what is BIM? BIM's lots of things to many people. The simple explanation would be that building information modelling is about everybody understanding the building through the use of some form of digital model. So that's a very basic and broad explanation there. But actually it very much suits what BIM's about. For example, if you're a client, if you're investing, say, in a cinema complex or something, the client will be very much interested in the theatre space, the number of seats, the capacity, the opportunities for retail and subletting for franchises and that sort of thing. So they would use the model to get net lettable areas and capacity information. If you're an engineer, for example, you could use the model perhaps to do energy analysis and optimize the design. If you're a contractor, you'll use the model for a different purpose. You look at the quantities for sure, because you need to procure these things in advance. You might also look at sequencing, making sure that big bits of plant can actually get through the various openings in the building as part of its construction and so on. So there's lots of different ways in which building information models can be used. So if everybody gets a chance to explore and understand the building through a model, then we can optimize that model, make the building better. One of the big drivers for BIM is the UK government's 2016 BIM mandate, which is very much just around the corner. That's really a driver for the driver behind that is change. The government are trying to introduce some change into the industry. that will make the industry more effective. This isn't about cutting out fees or slashing costs. It's about creating better value. It's about actually reducing waste. There's an awful lot of waste within the construction industry, not just waste materials, but it's about wasted time and effort. There's a lot of rework that happens on site that's inefficient. And one of the drivers behind the government's BIM mandate is very much to industrialize the construction sector so that the site work can be that bit more predictable, leading to better outcomes, lower risk, and ultimately better buildings. But it isn't just about the construction phase at all. It's about monitoring those buildings in use, learning from what works well, what doesn't work so well, and ploughing that back into future projects. Government spends around about 36 billion per annum on construction activities, and to not learn from what works well and what doesn't work so well in a building is not the right way to go about it. And a big driver behind that is to improve the built assets that the government have. The early years of BIM have been relatively successful since the BIM mandate was introduced in 2011, and the government have run various early adopter projects. And they have those projects have been audited and have resulted in savings. I think the 2013 to 2014 audited figures show approximately 20% saving for the government projects. So they're now able to build 7 schools for the price of 5, that kind of thing. Fundamentally, in the environment that I'm going to show you this morning, this is about building things with intelligent information. The generations of today grow up with tablets, iPads, digital Lego, if you like, and this is about creating an environment where products can be built into the design very easily, very quickly, but very robustly and accurately, so that some good analysis and insight and interrogation of the design can take place. So what I'm going to show you now really is a little bit of BIM in action. So I'm in a platform called Revit. Revit is one of the most popular platforms in the UK. It's used by lots of architects and engineers and designers to create their basic BIM design. So on screen at the moment you probably can see a plan view. This isn't going to win me any awards. I'd like to say I'm certainly not going to win the Sterling Prize for this building, but it's a functional building that is just going to allow me to do some quick introductory examples of how this platform works. So we've got a layout there. Now, traditionally with CAD, you would draw lines, shapes, and you would form elements such as doors, walls, roofs, windows, and you would create those just by simply drawing them. And with BIM, yes, you have to create doors and windows and so on, and ceilings, but you create them as objects, and these objects know what they are. So a door knows it's a door, a window knows it's a window, for example. And these objects then behave in a particular way. So you can place windows in a wall, for example, but you can't place a window in a door. The NBS National BIM Library, which I'll just show you on the right-hand side, is a library of free-to-use BIM objects, which includes a number of generic BIM objects as well as manufacturer's objects. So if I want to draw a wall, for example, I might look for a block. So I'm going to search for a block wall. And I can see a number of manufacturers there that offer various concrete blocks. And literally I can drag and drop those objects directly into my model, and then I can do something intelligent with them. So I'm just downloading that object directly from the NBS National BIM Library cloud. So all of these objects are online. And then I'm going to select the type of wall I want. There are some different types of wall, but I'm just going to select one of them. I'm going to copy that directly into my project. So once it's in the project, I'll just move that window out of the way. I can then draw a wall, and I should say I'm an engineer, not an architect, so don't critique my design. Now I've just drawn a wall in plan there, quite simple enough. But then switching to an internal view, you can see that wall has now been added to the entire model. So BIM isn't about creating plans or elevations, it's about creating the digital model. It's about creating the building digitally. So when I draw a wall in 2D, I'm actually not drawing it in 2D with lines as I would have traditionally done in CAD. I'm actually drawing with a wall, and I'm creating that wall. And walls can have properties and so on. Perhaps if I look for a door, it becomes a little bit clearer. So if I search for a door, again in the National BIM Library, lots of doors for different manufacturers. Yeah, there's lots and lots for a designer to choose from. I can select those based on the project requirements, of course. But let's pick let's pick one of these metal doors. So again, I can drag and drop, downloads that from the National BIM Library. And then that allows me to place the door directly within the wall that I've just drawn. Okay, so now I can place that door there, I can place another one there, and perhaps another one there. So this is a way in which I can start to build up my designs. You can see the two doors there. I can edit in this environment. So if I want to get rid of one of those doors, of course, I can delete that, and I go back to my level 0 plan, and you can see that door's been deleted. So you can immediately see the advantages of this type of environment for architects and designers. They're not having to recreate elevations and plans and sections manually, which was the traditional approach. You can make a change in any of these views, and essentially if you remove a door from a view, you're removing that door from the building, from the digital model of the building. It isn't just about the geometry. So for example, there are other things that can be built into the objects, such as lots of data. So if I look at adding perhaps a hand dryer to the toilet area on screen at the moment, again I can search for those objects, perhaps download one of these hand dryers, place it into the object, so into the model. So that's the hand dryer there. And the MBase plugin, whenever you click on any of these objects, it synchronizes, and you can see a picture of the product itself, manufacturer's description, its version number, contact details for the manufacturer, of course, and then lots of technical information about the hand dryer itself, such as its power consumption, options, performance data, everything from warranty information, physical characteristics, its operation, and so on. So it's this type of information that the government are encouraging industry to standardize on and make readily available, so that that information remains within the digital model. And when the building is handed over, both in its physical sense, so when the building's built and that hand dryer is fixed to the wall, but also in the digital sense, when this model is passed to the owner or the operator of the building, they can interrogate that digital model, understand what the maker of the manufacturer of that hand dryer is, what its warranty is, perhaps when it was last serviced, that kind of thing. So that type of information needs to be well structured and organized in a particular way. And that's part of what COBie, you may have heard about the term COBie, and that's basically just about structuring information in a standardized way, so that when clients get their building in a digital form, they've got standard tools which will read COBie, they can understand what that means, import it into their facilities management systems, and then manage the building far more effectively. The government is trying to introduce a far more effective way of maintaining and managing their built assets. There's a lot of opportunities to improve value and actually optimize how the buildings are managed and maintained. So designers tend to be time poor, and this kind of system really plays to that advantage because it allows designers to focus on what really matters. The information is built into the products, so they could trust that information is there. It's free for the designers to use, and there's a large library of objects there. So I'm just going to quickly jump back to some slides. There's lots of objects available on the web. There's a few there that are perhaps just more of the fun types that you can find. Because there's lots of objects available, there is inevitably quite a varied approach to how these objects are authored. And unfortunately, that lack of standardization really undermines what we're trying to do with BIM, not just in the UK, but worldwide. There is a real need to standardize BIM objects so that they can be trusted, relied upon. There are some objects that you wouldn't want to go anywhere near, but there is a growing quantity of good quality objects that architects and designers can trust. But work really has been necessary to help standardize that, and NBS has introduced the NBS BIM object standard. So this is a standard to help anyone that's in the business of creating objects meet some minimum requirements. These requirements very much align with the government's level 2 BIM mandate. That's the requirements for all projects that are government funded from April 2016 onwards. So the BIM object standard is a tool which helps manufacturers who are wanting to create objects themselves know what they need to do and what they need to focus on. The result of that is a library of trusted objects that then can interact with each other. So we've added some doors to this model, so I can now, using the Revit BIM platform, for example, create a door schedule. And I can schedule all those doors with standard information. I can compare the performance of the doors or the various features of the doors. Very much like you can do with various retail sites, you can compare for example, some cameras. You're going to purchase a camera, you might have a price point, but you may also have an eye on some of the features such as battery life or its shooting speeds and so on. That's possible as a consumer to view that information because the information has been structured. Quite hard to do that with construction products at the moment, but with standard information, door schedules or product comparison becomes far more possible. I'm going to perhaps pause there for a second and hand over to Tom Murphy from David Miller Architects, who's going to talk a little bit about how their practice and how Tom is using BIM, how their practice is benefiting from these technologies, and then then Tom will hand back to me and we can close the session after that. So bear with us a second when I just pass over to Tom.
Good morning, everyone. So as Ian mentioned, my name's Tom Murphy and I'm from David Miller Architects. So I'm going to talk to you today about BIM in practice. So what that really means is I'm just going to give you an insight into the journey we've taken at David Miller Architects in adopting BIM to where we are today, which is using BIM across all our projects on an everyday basis. So I think the reason NBS asked us to speak today is since adopting BIM over 5 years ago now, as I said, we are at a point where we're using it across all our projects, and we've seen sort of real benefits in the use of it, and we've been quite vocal about those benefits and happy to share them with the sort of the wider construction community. So I'm going to talk to you about 4 main things today. I'm going to share our general experiences since adopting BIM, the journey we've taken to adopting it. I'm also going to talk about the actual impact we've seen primarily on the business on adopting BIM. I'm going to look a bit closer as well about how we actually use BIM on a day-to-day basis, using some of the BIM tools that are around and how we've incorporated those into our workflows. And then finally, I'm just going to look briefly at some of the future opportunities we see for those embracing BIM. So just to give you a short insight into where we're coming from, David Miller Architects is a small practice based in central London. We've grown from 4 members of staff to 24 in the last 5 years, and our workloads are sort of fairly typical for an architectural practice of our size. So we work primarily on housing. That's a mixture of affordable and high-end. Schools is a big sector for us, as well as student housing, mixed-use commercial work, and some hotels. So our founding practice partner, David Miller, his sort of personal background is involved in sort of the solving of complex three-dimensional projects, some of which you can see here on the screen. So the practice's approach was always going to be, and is to this day, around the use of 3D software that can advance the practice's capabilities. So what was our sort of general motivation for adopting BIM? You could say that we had to do it. As Ian mentioned before, the government's level 2 BIM mandate is imminent. We're also seeing an increasing emphasis from our clients or prescriptive clients on BIM capabilities. But we actually came to BIM because we wanted to do it. Our previous workflows was already working in sort of three-dimensional software, but we were actually, because of the capabilities of those three-dimensional software, we were converting that to 2D to produce the drawings. So this led us to sort of analyze how we were working, and we felt that there was a real opportunity for architects to add value to the design process, but we were wasting a lot of time in the drawing production stage. So we were first attracted to what turned out to be BIM, first of all by the inherent opportunity to develop a project in a single collaborative environment without the need to go between 3D and 2D. As Ian showed you before, as you generate the model, that is essentially generating your production drawings at the same time. Also for the relatively young practice that we were at the time, the embedded quality control that BIM provides was a real benefit for us. Similarly, the consistency in output that BIM inherently provides you was really crucial for a small practice to gain and maintain clients. We also have since realized that analyzing kind of how we came to adopt BIM, but small practices, as we were at the time, actually have it easy. We sort of had no board or middle management to convince on its benefits. We didn't do any ROI calculations. We just felt that it was the future, and we just got on with adopting it. So in terms of giving you a brief overview of our timeline of adopting BIM, we first introduced it to the practice in around 2008. We hired an in-house trainer to give the staff members then training that sort of focused around our workloads at the time. And then we jumped straight into a £2.5 million Resi project to produce the drawings. As we gained more confidence in its use, we then repeated that on a number of projects. However, we were at this period reverting back to CAD sort of on projects where there was maybe crucial timeframes or maybe on complex refurb projects. In around sort of 2009, 2010, we made the commitment to use BIM across all our projects as a matter of principle. At this point, we hired a BIM champion who also structured our training for new members. And that involves, and still does to this day, an intensive bootcamp for all new members to mean that there's no distractions and they're up to speed with how the practice operates. Over the past few years, with a steady push over the last couple of years, we've really seen our capabilities grow as we push towards the level abilities. This is what we call the sort of contractual stage, and during this stage we've blown the BIM champion role apart really. We now encourage all staff members to promote BIM, look at potential new solutions for its use. It's also during this stage that we've seen us do our first BIM execution plans. We've also used the model for rapid energy modeling and quantity takeoffs. I've discussed briefly the sort of our journey to adopting BIM, but I'm going to look at now the actual benefits that we've seen on the practice in terms of the design process and in terms of the business. The image you see here is of 4 school projects that we've worked on, all different projects in terms of their size, their budget, their context, but they're actually all built on the same core components. And what it's trying to demonstrate is the efficiencies that BIM allows. As we build our model with some of the objects that Ian showed you earlier, our kind of office database gets richer and richer. And what this in turn leads to is a far more efficient design process for us as the designers. For suppliers, it gives you the opportunity to really create a far longer legacy with the products that you're promoting. And then for the client, it has knock-on effects in terms of the speed of production. So I'm going to look a bit closer at this. There's a screenshot here, which we're going to see a fly through shortly, of one of our school projects. Oh, sorry, it doesn't look like the, there we go. So what we're trying to show here with the screenshot is basically how we use the model on a day-to-day basis and the benefits we've seen it have. As I mentioned, we're a relatively young practice, but what BIM has allowed us essentially is to really punch above our weight with the projects that they're working on. You know, this kind of scale project pre-BIM would have had a much larger team on it, a much longer time frame. But as you can see here, the use of the 3D modeling really allows you to get a real immediate grasp of the scheme in its entirety. Now, whilst that's not really anything new, there's been 3D modeling software around for a long time. The difference here is that we're actually building our model with far more robust information. As Ian showed you before, you're actually building the model with components. The wall is a wall, and it has a build-up that is essentially going to be built. And for a young team, that really gives you an immediate grasp of the building process. But it's not just on the designers that this has a benefit for. We've seen DTMs become far more productive. When we show the model to our clients, they get an immediate understanding of what they're going to get and what they might not want. So it just creates a generally far more efficient design process and actual construction process because there's far less surprises at the end. You know, BIM's also really working for us as a single source of information. Whether the task that we're using the model for is a large-scale planning proposal, or whether it's to sign off on light switch locations, we're using the same model. But it's not just the sort of technical design stages that it's working for us. We do a lot of work for some of our local council clients at the inception feasibility stage. Now these sorts of stages, they're built around much tighter timeframes. Clients want to work out quickly whether a location or a scheme they want to develop is feasible. What BIM has allowed us with these sorts of stages is that you can very quickly demonstrate, first of all, the 3D proposals, but the difference here is that the 3D proposals you're generating, they can be rapidly validated from the same model. The area schedules, accommodation schedules that are so crucial at this stage, they're developed in a single source of information. When you sort of tie that in with robust contextual site information, such as blue sky data or point cloud surveys, you can really get a very immediate and robust understanding of whether an early stage project is feasible. We've also seen BIM kind of shift the way that you value a project. I mean, this has been a bit slower to happen, but we really see BIM models as providing a real opportunity to not analyze the building just in terms of its baseline cost, which previously was the only way to really measure the production information. What the BIM model allows you now is an opportunity to analyze the project's life cycle before it's even been built because of the information that we're filling our model with. So what about the costs of the practice of adopting BIM? We've estimated the cost per workstation for using BIM as around £10,000 per seat. Now that's in terms of both the software, the hardware, and the training. On top of that, we're investing around £30,000 a year for the past 5 years since adopting BIM, which for a small to medium practice may seem quite a large investment. However, when you look at that in terms of the proportion of annual investment against our actual fee income and technical staff costs in the magenta line here, it's actually far less alarming. Now, in terms of the bottom line, looking at our actual fee income against the BIM costs, during our initial sort of lonely BIM stages, we saw our fee income generally be fairly parallel against our staff costs. But as our capabilities increased and the opportunities for projects increased, we actually saw a sort of a sharp increase during our collaborative BIM stages. As we've pushed to expand our practice, again, the fee income has sort of plateaued against the technical costs. But actually, again, as our capabilities towards level 2 have increased, we've seen another rise in our fee income against those costs. And then also, when you look at it in terms of the construction value of the projects that we've been working on, that has had a sharp increase across the period since we've adopted BIM. In 2008, when we first came to BIM, the largest project we were working on was a £2.5 million resi scheme. Now we're at a point where we've had a £35 million mixed-use scheme completed, and we're on site with several £15 million plus schemes. So what I'm going to look at now is how we use BIM in practice in finer detail. So what I'm going to look at today is, first of all, how we've used BIM to really streamline our design and specification process. I'm also going to look at kind of what we expect from the supply chain and feeding into this process and really driving further those efficiencies. And I'm just going to look closely at one of the projects we've worked on and some of the BIM tools that we use to streamline our design process. So as I mentioned, we've seen real efficiencies in the design and specification process as we've moved from what we call a descriptive process, pre-BIM, to where we are now, which is a prescriptive process. So what I mean by that is that we're using BIM to really kind of continuously link the design and specification process. So one is continuously feeding the other. What the image here shows is kind of the versus the current process, where you would previously, sort of in a 2D world, you'd draw a diagram and then you textually explain that. What we're doing now is we're filling our model with 3D information which has data inherent within it. So if you look at that a bit closer, in terms of the design and specification process, the previous descriptive process, which many of us know very well, involved a very kind of linear design process arranged around the work stages. And then at sort of set stages within that process, someone would go offline and produce a specification. Now that would involve someone taking the 2D production information and kind of translating that into basically a text document. Now inherently that has inefficiencies within it, the time taken to translate the 2D design information, but also the risk in terms of getting something wrong or the ambiguities involved in translating it. So what we've used BIM for within our practice is really a prescriptive design and specification process. Through all the work stages and then from project to project, the design and the specification are consistently linked, and they're linked through the model. But really the key to the success of this is the actual information that we're building our model with. And the key to that is what we call structured data, which is what we're going to look at in close detail shortly. So what we mean by structured data is that, as Ian showed you before, the objects that we're filling our models with from the MBS library, we really need to know that those objects have the correct level of geometric detail and information, and are also quality assured, and they can be compared accurately. So when we say the correct level of detail, really what we mean is, as the sort of the image shows here, we don't want information that has too little information because it can create risk. But also at certain stages of the project, we don't want to be bombarded with too much information. Sometimes you can spend too long on information that actually no one is going to use. So for the right stage of the project, we need the right level of information. What we also need as designers is a quality assurance that the information we're inviting into our model is robust and reliable. This isn't just because flaky information can cause, risks or disruptions to our design process, but also the information we're inviting into our model now can live far longer, as I've shown, from not just one project, but from project to project. But fortunately, there's tools around now, such as the MBS object standard, which for designers provides a level of quality assurance that the objects can be compared accurately. And for those creating the objects, it gives you almost a checklist of the information that we want to see. So I'm going to look at a typical project that we work on at David Miller's, and I'm going to look at it in terms of how we use the model with some of the BIM tools around now to sort of streamline our design process. So this is a mixed-use scheme in central London. It was for a very experienced developer who had a very clear idea about the type of design and spec that they wanted for the project. It was a mixed-use residential scheme, so with affordable shared ownership, high-end resi, and some ground floor retail. It was also a very complex stakeholder structure, so we had the end developer, as I've mentioned, but also a client's agent and our contracted client, all with different goals and sort of things that they wanted to get out of the project, which we had to manage. So using the MBS plugin for Revit, which is Revit being the software that we use, we can very quickly build our model with the objects, as Ian demonstrated earlier. Now, as I mentioned, on this particular project, the developer had a very clear idea of the specification that they wanted for the residential units. So it meant that having that initial idea, we could build our model with the objects direct from the BIM library. And then what that also allows us to do using the MBS plugins is link that model instantly to a spec and generate a spec from it. So very quickly, within 2 weeks, we had what could have been a very complex task for a client, which was to initially understand the scheme and the cost of it from the products they wanted. But we could generate that extremely quickly through utilizing the MBS plugins. So once the specification was generated from the model, that meant that they were automatically synchronized, so that any changes we made within the model were automatically updated in the spec and vice versa. Now, this was really crucial on this project because, as I mentioned, the client had an initial idea of the objects they wanted and the specification they wanted for the scheme, but then they wanted to do a cost review. So that meant that using the MBS library, we could, in front of a client, compare objects to objects in terms of their performance and their aesthetics. But that was only really able to be done through the object standard that I mentioned earlier, because we knew as designers that the objects that we're comparing were accurate. And that meant that any decisions that were made in DTMs on kind of products that they wanted to change, it was automatically updated in the spec. And the Revit tool also allows you to create spec items from objects that are bespoke. So, this was a high-end scheme which had some bespoke elements to it, but we could then, even if there wasn't an object directly associated with it, it meant that the Revit plugin allowed us to post-associate it with the spec. So hopefully what I've demonstrated is that utilizing BIM and MBS Create as our specification tool, using tandem with the National BIM Library, it's really kind of filled in the missing link between the design process and the specification development. It means that as the project evolves, because the data is always structured and quality checked, it means they're continuously updated, but because they're linked, and also the information that we're filling the model with is structured. It just ultimately leads to better designs and outcomes for the end users. So finally, I'm just going to summarize what we've discussed and how we see that impacting the future for architects and BIM. You know, we see sort of real opportunities for the supply chain, first of all in the work stage involvement and project stage involvement. We also see a shift in the best value of the model from, as I mentioned before, from a lowest cost to the actual end life cycle value of the project. And we also see, through the use of BIM tools, really driving efficiencies in the design and specification process. So our personal experience as an architectural practice over the last kind of 10 years, we've seen our project involvement really shift from the previous traditional role of the architects from start to finish, has really been squeezed to kind of the sort of the concept design stage and technical design stage, and sometimes during the construction stage. However, as I mentioned before, because of the data that we're filling with our model with, we really see opportunities for both designers and suppliers in the level of or stage of the project that we can get involved in. Particularly, we see real potential opportunities for designers and suppliers in the handover and the use stages of the projects. Although sadly, the latest BIM survey suggested that only 12% of people are really passing on their model to those who use it. But because of the data that we're filling our model with, there's a real opportunities for those that use the building to inform the design stages, and suppliers and designers can really have a say in how that's done. As I've mentioned also, we see a shift from the kind of the previous interpretation of 2D information to just a lowest cost model. Because of the data we're filling our model with, there's real opportunities to understand the real value of a project. Now, what that means is for kind of architects and suppliers, for those that are embracing BIM, they can drive real efficiencies for clients in the building's construction and use, which will provide an opportunity for those embracing BIM in the future. And finally, as I've demonstrated through the use of the BIM tools integrating with a BIM workflow, there's real efficiencies to be had for the design and construction stage. If these tools are used accurately, it means that we can rapidly fill our model with data that's structured, which in turn will provide efficiencies. So really what we're saying is that don't be scared of BIM. BIM provides a real opportunity for those embracing it to drive their own efficiencies and the client's efficiencies, reduce risk during the design stage, and really set yourself apart from the market. Okay, thank you for listening.
Okay, thank you, Tom. It's Ian again, and we'll just wrap up with a couple of points from me. I'll just close down Tom's slides and jump back to the National BIM Library. Okay, so you've heard a little bit from Tom in terms of how Tom and his practice colleagues are using BIM. Tom is one of many that are doing very similar, and they're using BIM to the advantages of their practice, but fundamentally to create better buildings, not just in the construction phase, but throughout their entire life. When you look at the National BIM Library website on nationalbimlibrary.com, there is lots of free help that you can call upon to help you understand BIM. In particular, BIM, the BIM object standard that Tom mentioned, that can be downloaded free of charge in PDF form. Alternatively, you can browse the standard online. One of the benefits of browsing the standard online is that if you log in, as I will do now, there's lots of technical guidance to help you understand what the standard requirements are, what the requirements of a good quality BIM object are defined in the standard, and then there's some guidance to help you understand some of the background to that. So if there's manufacturers out there that would like to create objects themselves in-house, or procure objects, or get some help creating objects, please do have a look at the NBS BIM object standard. It's used by many, and it underpins what I was talking about initially in terms of creating that common platform, that common consistency of information that goes into a BIM object, and how the BIM objects can meet the needs of the government's Level 2 BIM mandate, which comes into force April 2016. Of course, you may not want to create objects yourself. You might want to get others to help create them for you. NBS can create objects for you. We can host them and place them into the National BIM Library and get them in front of your audience, get them in front of people like Tom and others. There are lots of people that have a real and pressing need for your products in this digital BIM form, and that's a really good opportunity for you to get out in front of those designers. So just flipping back to Revit. As a summary, when you're thinking about BIM, please don't forget the quality of the data. We see lots of objects from manufacturers that perhaps are geometrically good, they cover the physical characteristics well, but they really miss out on the data. The data needs are very clearly defined in the NBS BIM object standard, so please have a look at that. And if you get stuck, if this is something you would like some help with, please get in touch with us. We'd love to help. We really do believe in standardized and consistent information across the industry. It will revolutionize how the construction industry works as we go forward into the digital world. Don't forget that deadline, that government mandate in 2016, April 2016. The requirement is quite simple, and the requirement is for the construction team to provide a 3D model of what has been built, together with accompanying technical information that's structured in a standardized form. You know the dimensions of your products, you can handle the geometry well already, you know the technical properties of your products too. We just need to structure them in the right form that works with the UK government's requirements. It's not as hard as it sounds, and we can certainly help you with that. Think carefully about how you create your BIM objects and ensure they are to the right standard. Think about the terminology and get your objects validated. So, for example, the National BIM Library offers a service where we can check, verify and certify your objects to that standard. That way you've got assurity and assurance that your objects are fit for purpose, and then through the National BIM Library we can make sure those objects actually work hard for you. We can give you that maximum reach and appeal to the market. There's a huge demand for BIM objects. Awareness of BIM has gone from the low percentages back in 2011 right up to 90% plus. So there is a huge awareness there now, and there's an opportunity there for manufacturers to fill that gap. Thank you for listening. I'll try and pick up some questions that I think have been raised. If you just bear with me a second, and I'll look up some of the questions that have been asked. I think there's a question posed for Tom. If I can present this to Tom and give Tom a quick chance to reply. One question raised by a delegate. Tom, do you see BIM and the technologies such as Revit as being as important to manufacturers as they are tech? So you've demonstrated how BIM is helping you as an architectural practice, but how do you see BIM helping manufacturers?
The short answer to that would be yes, we do see benefits for manufacturers. I think, and that would sort of be twofold. I think from a business point of view, as Ian mentioned, you know, not only is the awareness of BIM increasing, so there is demand for manufacturers' information that is BIM compliant. But I think if you sort of think longer term, you know, previously with the sort of 2D world, we'd specify projects, and it was on, you know, a much more kind of you know, sort of personal level. You know, maybe someone would prefer a particular product, but now there's a real opportunity for those that embrace BIM to really get their information out to a much wider market. You know, the information that we fill our model with, your products, they will live not just kind of in the person who's specifying its mind, but it'll actually live in the model. So, you know, for me, I have products or manufacturers that I have a preference for. I might specify that on a job, put the objects in my model, but I might leave David Miller Architects. However, the model's still with David Miller Architects, and the object is still there, and then that will continue to sort of, you know, be translated from project to project if we like it.
Brilliant, thanks Tom. One final question that has been posed. Manufacturers of products that are perhaps not particularly defined in 3 dimensions, so these might be insulation or carpets or those kind of products that are maybe sold in rolls, or what I would describe as formless, so they can fill kind of any shape. How do they work in BIM? That's a good question, because there's lots of products out there. They're defined as a layered object, and what essentially a layered object is, it's defined in 2 dimensions. So it may have a thickness, it may have a build-up also, there may be a number of components that makes up that build-up, but they're defined essentially in 2 dimensions. So there might be an outer skin, which might be 10 millimeters, there might be an inner skin, and a further outer skin, which essentially creates a sandwich, creates a layer. You can have many layers in a layered object, or you can just have a single layer. And essentially we can define products such as carpets, insulation in that form that then allow manufacturers to create objects that can be delivered through the NBS National BIM Library, that can be part of the NBS plugin. So the NBS plugin that Tom referred to is a tool that's built into Revit that allows designers ready access to those objects at the point of need, as I dragged and dropped those objects directly from the plugin. It does other things, and if you want to find out a little bit more about how the plugin works, get in touch with us and we can show you how you as manufacturers can benefit from your inclusion within the NBS National BIM Library and the plugin itself. I'm going to call it time there for today's session, which I hope you found useful. On screen there are some next steps. If you want to find out a little bit more, we'd love to help. There's lots of things we can do to help you. Even if you're just toying with the idea of just creating 1 or 2 objects, we can help you get on the right track. We can give you lots of information that will steer you and make sure you succeed as quickly as possible with that. If you need some further help, of course, we can help author those objects for you. Either way, whether you create them yourself or whether we author them for you, there's a real opportunity for you to get in front of the market, get in front of designers, and include your objects in the trusted NBS National BIM Library. Some information on screen there. You can download the NBS National BIM Library product brochure. The NBS National BIM report for manufacturers is also worth a read. It gives a bit of context and a bit of intelligence in terms of why the manufacturer, where the market is at, I should say. And if you're still frightened by all of that, there is a guide aptly named BIM for the Terrified, which you can read and get up to speed with how BIM can help you. Of course, don't be frightened to contact your account managers or our customer services team. They can take your query and we can make sure the best person gets in touch with you to help you move forward with BIM. I hope you found today's session useful. Many thanks to Tom Murphy from David Miller Architects for his presentation, and best of luck with your BIM journey, and love to help you, so by all means please do get in touch with us. Thanks for listening.